going to be talking about multiplying and dividing integers. Multiplying and dividing integers are way easier than adding and subtracting. And so I think that's what we're going to be able to go through this whole chapter in 1 week. So we're going to be able to do it pretty quickly. And then move on. But before then, I love a song. So we're going to watch this video. It's going to teach you an integer song. Okay? We'll listen to it again. Okay, so that's basically our whole lesson right there, wrapped up in the whole week. Is when you're multiplying and dividing integers, if they're the same signs, it's positive. Different signs are negative. So I would write that. Never wants to do correctly. Okay. Same signs. You're going to get a positive answer. If they're different signs, you're going to get a negative answer. Now, Coach Jones did show me something too. If you make this triangle, positive, negative, negative. Okay? So the way it works is if I have negative 2 times negative 3, negative, you mark out what you have, negative and a negative, you're going to get a positive. If I had a negative and a positive, so if I cross out a negative and a positive, I'm going to end up with a negative. Now if I have a positive and a positive, that's just old-fashioned what we've been doing in the past. And if you forget these rules, think about it. If you have 2 times 3, what's your answer? 6. You had a positive and a positive. Same signs gave you a positive. Okay? We're going to go through this really quick. I have a feeling it's not going to be too difficult. So just looking, is this going to be positive or negative for problem A? Why? Same sign. So 30. Part B, positive or negative? Why?
But they got different signs.
Different signs, negative 12. Remember that when a number is touching a parenthesis, that means they're being multiplied. All right, y'all do 1 through 6 real fast. You hear Miss Bowen's class. All right, number 1, positive or negative? Positive 25. Number 2, positive or negative? Positive 9. Number 3, positive 56. Negative 24. Negative 24 again.
Zero.
And 0. And 0 is neither positive nor negative. It's neutral. Alright, pretty easy, pretty straightforward. The biggest takeaway here is when we're looking at exponents. Remember, exponents tell us how many times we're going to copy down the base number. So if I have 3 to the 5th power, that means I'm going to copy 3 5 times. There you go, like this. Okay? If I have a negative 3 to the 5th power, though, like this, that negative is not necessarily attached to the 3. So that means that 5 is only going to the 3. So I would almost rewrite it as this and this. Okay? So I would do 3 to the 5th power, and then that negative is on the outside. Do your calculators real quick. What's 3 times 3 times 3 times 3 times 3? 3 to the 5th power was what? So I get 245, and then I have this negative on the outside. So 2 what? 43, my bad. That's why you said 45. Okay? Well, how do I get the negative to go with the exponent? If it looked like this, then the negative is attached to the exponent. So it would be negative 3 times negative 3 times negative 3 times negative 3. 1, 2, 3, 4, 5. Is this going to end up being a positive answer or a negative answer? What makes you think that? Okay. Well, here and here are going to make a positive, right? Here and here's going to make a positive. And then we're going to bring down a negative. Here and here will make a positive. And I'm going to bring down a... So what is it actually going to be? Negative. When you have an odd number exponent and you're dealing with negatives, your answer is going to turn out to be negative. Okay? But if I had, let's say I had 5 to the 6th power, negative 5 to the 6th power, negative 5 times negative 5. 6 is going to be positive or negative? That'll make a positive, that'll make a positive, that'll make a positive. A positive times a positive makes positive times another positive. It's going to make a positive. So if your exponent is even and you're dealing with a negative, you'll come up with a positive. But if it's odd and you're working with negatives, it's going to be negative. So if you see here, we have parentheses and no parentheses. So because this is parentheses, this whole thing is copied twice. So what's our product? 4, positive 4. But in problem B, there's no parentheses. So what's being copied twice? Just the 2. That negative stays on the outside and 2 is being copied. Well, 2 times 2 is 4 times the negative is going to give you negative 4. With multiplication, does it matter which order I multiply things? Does anybody know what property that's called? Commutative property of multiplication. When you can move the numbers around and still get the same answer, that's the commutative property. Negative 2 times 17. Negative 34 times negative 5. What are you going to do first in D? Parentheses first. We have please excuse my dear Aunt Sally. So we're going to do inside the parentheses first. So we've got negative 3 plus 4. So you're going to go back to your addition rules. Negative 3 plus 4. Why is it 1?
Because it's technically just subtracting 4 minus 3.
Right. Different signs means I'm going to subtract. 4 take away 3 is 1. 4 is bigger, so I keep it signed. So I end up with negative 6 times 1 plus 6. So we're done with parentheses. We have no exponents. We have multiplication,
Well, then negative 6 times 1.
which gives me negative 6 plus 6, which gives me 0. Alright, on your own, I want you to try 7, 8, and 9. Number 7 should be real easy. Alright, number 1, what we get? 0. Anything times 0 is 0. Alright, what was the first step in 8?
You got to do that.
Exponent. 3 times 3 times 3 gives me. So I end up with 24 minus 27, which gives me negative 30. Alright, what's the first step on number 9? parentheses, 3 take away 5,
Negative 2.
what's my next step?
You gotta multiply 7 times negative
Which gives me negative 14. And now I have to remember my subtraction rules.
2. Keep change opposite.
Keep the first, change opposite. So my answer just ends up being. As I was walking around, some of us forgot about those subtraction rules. They'll be sneaky and they'll get you. Especially when you're working on multiplication and division, then all of a sudden it flips. You gotta pay attention to those. Okay? Alright, let's look at this one first about the mountain. It says on a mountain, the temperature decreases by 18 degrees for each 5,000 feet, or 5,000 foot increase in elevation. At 7,000 feet, the temperature is 41 degrees. What is the temperature at 22,000 feet? Justify your answer. Where do we even start?
You got to figure out.
There's a lot going on.
You need to figure out how much the temperature is going up.
Is that what you're going to say? We need to figure out the overall change in temperature because that's what it's talking about, right? Is the change in temperature? Well, to figure out the overall change in temperature, we have to figure out the change in elevation because that's what it's saying. Your temperature is contingent on your change in elevation. So if I start at 7,000 feet and I climb to 22,000 feet, what's the distance there? How do we figure out how far apart they are? What do we have to do? Subtract. So 22,000 or 22 minus 7 gives you what?
15.
So we've had a change in 15,000 feet. So we know that part.
Oh, it changed by 3.
And then first, it changed by 3, so you just do,
Where'd you get the 3 from?
because if 5,000 times 3 equals 15,000, because you just do 5 times 3 equals 15,000.
So we've got 15,000 feet. Okay, we know that for every 5,000 feet is what we're looking for. So we want to know how many times can 5,000 go into 15,000. And so when we chop box and do the opposite, well, that cancels, that cancels, that cancels. So 15 divided by 5 is, okay. So we know it changes 3 times. What do we do with that 3?
You just basically take 41 times 18 and put the answer and subtract 18 and take that answer and subtract 18.
I like Mackenzie's idea. Tell me why you multiplying by 3. It says 18 degrees for each 5,000 feet. So we go up 5,000 feet, it goes up 18 degrees. We go up 5,000 feet, it goes up 18 degrees. We go up 5,000 feet, it goes 18 degrees up. Because it's like you get closer to the sun, so it's getting hotter and hotter and hotter. Oh, sorry, it goes down, sorry, which makes sense. Anyways, ignore that. Decreases, thank you. Important details. So it goes down, down, down. So what's 18 times 3? 18 times 3 is what? 18 times 54. Okay. So we've had a total change in 54 degrees Fahrenheit. Decreases means it's going to be subtracted, right? Where did we start temperature-wise? So 41 degrees Fahrenheit, take away 54 degrees Fahrenheit.
Negative 13. Negative 13.
It's going to be negative, because negative 13 degrees Fahrenheit. That had several different steps, and it has a lot of information coming at you. You have to go, what is the goal, and what do I need to do? In my head, when I was reading over this, like I was having to see a picture of it to get a grasp of what I was doing. And so sometimes you may just need to draw a picture. Okay? Alright, we're going to hold off on the phone one today because I'm going to let y'all get to your IXLs. We'll probably fly through these pretty quickly. I don't care if you listen to music while you do these, as long as you don't start bombing. I'll sign off your IXL cards. I did get IXL treats, so as you finish your IXL cards, you can trade them in for